Hello, dear participants of Nordic Testing Days. We're back from lunch. I hope you did enjoy yours. We did enjoy ours. And now it's time for keeping your cup of coffee close and moving on to the next speaker. And this is Benjamin from Germany. I hope he's with us. Hi, Benjamin. How are you?
Hello, I'm good. How are you?
All good here. It's a little bit surprising to see that we have better communication now than in a lot of the CNN or BBC, these foreign correspondent cases.
Absolutely, yes.
So before we get started, then I looked at your background, and it was quite fascinating to see that your career trajectory, so to speak, has been in a reverse fashion from for the typical way. So normally testers turn into developers, but with you it has been vice versa. So
Right.
can you a little bit explain what happened?
Yes, I can. I used to work at Ubisoft in the tools and services team, so providing tools and services for various online games. And in this team, I got in touch with software testing, especially Selenium and integration tests and unit tests. I haven't been in touch with those before, and I became fascinated with this. So I was getting more and more into this topic, and then one day I saw a job ad for a test automation engineer, and I thought I maybe could do it with my limited experience, and it was one of the best decisions I ever made. So for 5 years, I I was a software development engineer in test, so to speak. So I never gave up development, but I kept my focus on testing.
Okay, but you've been working in quite a challenging industry, specifically making computer games, which are notorious for long hours and, in some cases, not so great quality. I think Cyberpunk jumps to mind as of late. So, what is your experience from the other side of the table?
Um, it's difficult, but in my role and also in my current role, as I will explain in the presentation, I am not directly part of game development anymore, so I don't really have to deal with those crunch times. But I know they are there, and it's maybe one of the worst aspects of the gaming industry. Yeah, but with the limited quality, that's why people like me are now in demand also by the games industry, because they really want to change that, and they really want to change their quality processes as well.
Just out of curiosity, so have you played Cyberpunk yourself?
No, I have not.
Okay. Um, But I think it's time now to give the floor to you uh, and have your presentation.
Thanks a lot. All right. Hello, everyone, and welcome to Simplifying Your Test Runs with Make. I'm really glad to be back here, even though it's virtual, and I really hope we can meet again next year in person. And during this time between the acceptance of my talk and the and this time now for the conference, this talk has changed quite a bit, as you will see. So let's see. Let's get me out of the way. I mean, we talked about this a little. I'm a test automation engineer now with 6 years of experience. I have 20 years of development experience overall, and I actually just switched my job back to Ubisoft after 5 years at Trivago, and now I'm a automation engineer. But still with a strong focus on quality and testing. So this happened literally 3 days ago. So I'm really, really new at my old company. That's me out of the way. A little bit of credits. Two talks and articles come to mind. One is Makefiles in 2019, Why They Still Matter by Simon Bruggen, who was a colleague of mine at Trivago who introduced me to the topic. And also the Useful Harmless Spectrum by Felix von Leitner. It's a talk during the Chaos Computer Conference 2019 that got me thinking about the philosophical aspects of it, as you will see. So let's start. But let's not start with Make itself, but with How I Met Your Mother. That's a TV series that you might remember. If you don't, it's not important. It's more about the context of it. This is from an episode called Architect of Destruction, and the main characters, Barney and Ted, have a conversation. And Barney says, I'm going to give you 4 words to live by. New is always better. And Ted replies, and this theory applies to everything. And Barney says, everything. So, is new always better? That's what I was thinking about then. The fact is, developers love new things. They love playing with new technologies and using all the cutting edge stuff that you find. But there are some problems with this. Yeah, of course, learning new things is a crucial skill. And especially in this IT industry, you cannot afford to lose touch with the current technologies. Otherwise, you will fail in a few years. The problem that I call the new is always better dilemma can be broken down into 4 things. One is familiarity. So, getting comfortable with new solutions takes a lot of time. I mean, it's easy to quickly play with something or follow a basic tutorial, but using it really, that takes a lot of time. Also, maturity, an aspect that is often overlooked. If you have software that is cutting edge, it can have major flaws and it can also have unwanted dependencies. If you look at new JavaScript frameworks, for example, they pull in a lot of dependencies that you might not be aware about. Management can be a problem. I have seen occurrences where a proof of concept of a new tool using new technology was perceived by management as close to final and then pushed to production in this state. And also, what's commonly known as the bus factor, but one colleague of mine called it the tractor factor, which I like better. So a single developer can be the only one in the know. If a single developer is the only one learning about a new tool and then just implementing it by himself in his team, and the knowledge sharing processes are not that good, if he is hit by a tractor, then the whole team does not know how to maintain the current state. And of course, if you learn a new tool, you want to use it. And there's a famous quote by Abraham Maslow from 1966 in The Psychology of Science. He said, I suppose it is tempting if the only tool you have is a hammer to treat everything as if it were a nail. So, whatever new tool you have at your disposal, you want to use it for every problem you see. So, that leads us to Make. And Wikipedia says Make is applicable to any process that involves executing arbitrary commands to transform a source file to a target result. And that doesn't really tell much, but it's also accurate because Make can be used for a lot of use cases. A few facts about Make. It was invented by Stuart Feldman in 1976 at Bell Labs, so it is actually 2 years older than I am. So for software, it's very old. And it initially was a build automation tool for executable programs, such as C programs. It is still built into Unix, Linux, and macOS. On Windows, you have to go a little bit of an extra mile to get it running, like installing it via Chocolatey or Cygwin, or there is Makefile Windows, which I had a play with, and I can tell you it works. So it's basically available everywhere. There are a few cons about using Make that I need to mention. It can be hard to master if you write Makefiles. It is dependent on tabs and spaces, which I really dislike. So that's why I also don't like YAML that much, or Python, I'm sorry. And bugs with Make can be tricky to figure out because the error messages can be misleading sometimes. But there are a lot of pros. Like I said, it's basically available everywhere. It's a proven solution. It's consistent across local and CI builds. So whatever you run with Make on your local machine can be run without any modification on virtually any build systems out there. It's easy to learn, especially as a user, as you will see, and it is never out of sync with documentation because Make is so easy to read and to follow that most of the time there is no separate documentation necessary, especially if you use it across all of your projects. So yeah, you will see that it simplifies, especially for newcomers, to work with your with all of your projects. Make has a few different parts, and if that bores you with technology and stuff, but I have to go through this. So make is the name of the tool, and the thing you run with make is called a makefile. So make looks for a file called makefile in lower or uppercase and runs this automatically. You can provide a file other than makefile to run, but the easiest is just to call it makefile. And it returns a status code of 0 if it runs successfully, which makes it ideal in CI CD context. So down there you see the invocation, so it is actually really easy. Just run make, pass in a few options and a target, and that's it. So the operation is straightforward. I will show you. You have rules in Makefile, and a make rule typically creates a target file. So that's the history of make. It is meant to create files, but in test runs, we typically don't create files. Maybe a test report, but we deal with files that are already there. But you can also do that. It's mostly dependent on timestamps. I will show you in the next example what that means. And it can also be the name of an action that does not produce a target file. And then you have the recipes, and the recipes are the action that make uses for rules. It can be one or multiple commands per rule, and that is something that you have to be aware about. Each line has to be started with a tab. So you need an editor if you want to write makefiles that keeps your tabs. It doesn't substitute them with spaces. So that is a very simple makefile. It has the dependency.txt as a rule. So make expects this rule to produce a file called dependency.txt. And we're doing that just writing hello world to a dependency.txt file and then echoing file created. We have the @ in front of the echo, so the command itself won't be printed on the command line. There you see, if we run make, it will just print file created. And you see that the dependency.txt is created. And if you run make again now, make reports dependency.txt is up to date because it keeps track of the timestamp and sees, okay, this file is already present, so I will not produce it again. And you also see that make is the only command you have to run. You don't have to provide the name of the rule. You can, but make typically takes the first rule it finds and executes it. Prerequisites. Typically, you don't have a rule that produces something without any dependencies. In this example, we have the final.txt, and the final.txt rule that produces a final.txt file expects a dependency.txt. So we can specify the dependencies between the rules by using colon and then listing the rules that this rule is dependent on. So the dependency.txt, it is doing exactly the same as before, just writing hello world to a dependency.txt file. If you run this, you see that the dependency.txt and the final.txt are both created. And then if you run make again, it will say final.txt is up to date. If we now remove the dependency file and run make again, make will execute both again because it will see that dependency.txt is missing. It will execute this, and then it will also re-execute the final.txt because the dependency has changed. So that is the basic mechanism of make. Well, what happens if you have steps that don't create files? Like here, we have the makefile from before. And now we want to have a clean step that removes the dependency text file and the final text file. So this would mean that when we run make now, it will first remove both files, then create the dependency.txt file, and then create the final.txt file. The problem with this is if you, in the future, have a file in the directory called clean, that might happen. This step will not be executed by make because it expects that the rule name is a file. So to prevent that, there is this .phony. This tells make ignore any file of this same name and always execute this. So now, if we run make, we will see that first the files are removed and then they are recreated. And if we run make again, because those files are removed at the start, make will run all the rules after it again. Build order is really important in make. If you have a make file like this, it might look that everything will be executed, but it is not. Here, make uses the first rule it finds, which is clean, and you see that clean does not have any dependencies. That means that all of this will not be executed, just the clean. I can show you this. Here, you see that it just says clean up all files, and that's it. And you have to be careful about this because sometimes it might seem that you are done writing your Makefile, you execute it, everything is all right, but it is not executing what you want. So an easy way to prevent that is reverse the rules. So instead of putting clean on top, put the last one on top, which is in this case test. And test is dependent on deploy. Deploy is dependent on build. Build on clean, and clean is the last one. So you see deploy on build, build on clean, and then clean is the last one. And make will go through this, check the dependencies, and then execute those rules in reverse. So now you see that all 4 steps are executed. Most of the time you have some kind of parameter or even multiple ones to pass in, because you don't want make to do the exact same thing every time. And that is also pretty straightforward. In this example, in the top line, I said browser question mark equals Firefox. The question mark equals means that if this parameter is not set from the outside, it will take a default value. And this default value is Firefox. I'm just assuming here that this might be a browser-based UI test. And the test rule has echo testing with browser, and then by using the $sign and curly braces syntax, you can just use this parameter. So if you run make, it will say testing with browser Firefox. And if you want to override this, you just say browser equals Chrome, and then it uses the browser Chrome. Simple and straightforward. This is just as a tip, and I don't expect you to memorize this. I will, in fact, give you on the next slide or one of the next slide a QR code where you can download all this example code if you want. So in this case, we want to show help on the command line if the user just types make. That's why I put the help rule at the top. And through this really cryptic command, this will parse the Makefile itself and take the comments that I marked in green here and print this on the command line along with the rule it belongs to. So you see it here. If you just type make, it will execute the help and print it. You can also execute it by typing make help. And then if you type make test, it will actually execute the test rule. So this is how you can invoke specific rules in a Makefile by just typing make and then the name of the rule. So this is also nice for testing make rules and make targets that are in the middle of make, and you don't want to rearrange everything when you want to execute something in a different order. Here's the example code. I put it on GitHub in my user account, and you can just download it and look at it and tell me what's wrong with it. So I hope you agree with me that this is not too complex. I mean, don't get me wrong, the make help, the manual is over 300 pages long. So there's actually a lot more you can do, also very specific syntax. Like if you want to check for parameters, if they are set or not. It can get a little complicated, but that's not the point. The point is to make it simple for the users of it. Speaking of simplicity, Stuart Feldman, the creator, said in The Art of Unix Programming, makefiles were text files, not magically encoded binaries, because that was the Unix ethos. Printable, debuggable, understandable stuff. And I agree. I mean, it is very understandable. If you read through it, you don't really have to know all the details, but you can roughly grasp what a makefile is doing if you name the rules in a consistent way. So it's actually limitation as an advantage, because whenever you're limited, it's much easier to learn and to use than when you have a framework that can virtually do everything. That's a real world example. I don't expect you to read through this, but this is a Selenium test that we used with a Maven invocation with a lot of parameters, but those parameters are not always needed. And this was impossible to document because there are so many dependencies between the parameters, and it was just a pain. Also, to use it in CI/CD pipelines, I don't want to go back. So with a make approach, it actually looks like this. We created a rule test local that uses the local browsers for this test, and you just pass in a base URL and one or more browsers. If you want to test on a test grid, we made it so you could just change the test local to test grid, and then it would execute on our test grid. And once you have the basic makefile set up, it's really easy to add features like specifying multiple browsers and devices and filtering for specific test features. So it's really, really flexible because in the end, Make does not care what the recipe is. It just cares about rules and dependencies. So I want to end with a few points that every project is different, and it can be very different frameworks, different technologies, different languages. You should always use the right tool for the job, not the tool that you currently have at your disposal. Very important is to decouple progress from technology. Don't think that you're only making progress if you're using new things. You can also use old things in creative and useful ways, and this is still progress. Testing and software development is a team effort. So the goal is to make it as straightforward as you can. And I think Make is a great tool to do this. So you remember this conversation from the episode of How I Met Your Mother? I rewrote it a little bit. So now I'll say, I'm going to give you 5 words to live by. New is not always better. And Ted says, I agree. Thanks a lot. My name is Benjamin. You can reach me on Twitter at BischoffDev or check out my blog, Software Tester Blog. I put the QR code there. Thank you.
Thank you, Benjamin. It was very hands-on, I would say. So thanks for that. So it was cool seeing some code being written almost live. But there are some questions as well. So first one is that the question: where do you store your make code? So is it reusable across the team?
We typically store our make files in the repository of the project that is being tested. Or the release engineers also store their make files in the repository that build the project. We don't only use it for testing, we also use it for building and deploying and all the steps that are necessary in a CI/CD context. And since we store it in the same repository as the software under test, everybody who checks out the repository instantly has this. And of course, it can then also be reused.
Okay, excellent. It's actually fantastic to see that there are some. You said 1976 is the time when this tool was kind of put up and it's still being used for good benefit.
Yeah, the thing is, it is done. I mean, it does exactly what it's supposed to do. There's nothing that can be improved. And yeah, there can be software that is actually finished.
Yeah, and the nice thing about it, about the old software, is that it usually runs really fast, especially with modern hardware. Another question, maybe on the flip side of it, what is the newest tool in your toolbox? So you spoke about a lot about old tools, but what is the most cutting edge, bleeding edge stuff that you're using?
Oh, well, yeah. I think, we recently moved to cloud, to Google Cloud, and also to GitHub Actions as our build systems. So yeah, that's pretty cutting edge, I would say. Also, we're starting to look into the newer test frameworks that are out there. Also using Selenium 4 already for a long time. Yeah, so of course it's possible to mix and match old and new tools if you see it benefits you.
New tools, old school. One more question here. Is it correct that with Make you can build your own, or you can build your continuous integration pipeline?
Absolutely, yes. You could use Make only to build your pipeline. What we do is we have modern pipeline like the GitHub Actions or Jenkins or whatever build server you use that also has stages and steps within stages. And in those steps, we execute specific Make targets. So we don't just trigger one Makefile that does everything, but we use one Makefile and trigger specific parts of it in our build pipeline. That gives us way more flexibility. So if we want to change something, we don't have to touch the Makefile. We can just call specific targets in just a different order.
Okay, very useful. And finally, quite contrary to your topic, is do you know any good alternatives for Make? That's probably a question from somebody in the audience who does not fancy the tool so much.
Well, for me personally, using Make made a huge difference. So I don't think it's a bad tool. It, like with every tool, it depends on how you use it. You can use every tool in a bad way. So you have to put a lot of thought into it, no matter what you use. So I disagree with that. I don't think Make is a bad tool. But of course, if you don't want to use it, you just use any other build server. You can even use files or shell scripts if you want. But yeah, I haven't really used anything else because I like it so much.
That was a good answer. But thank you very much, Benjamin. And we are really looking forward to seeing more games coming with higher quality, thanks to you. Thanks a lot.
I'll try. Thank you for having me.